September 1992, an American spacecraft heads for Mars, a quest to the Red Planet. A year later, as it tightened into Martian orbit, NASA lost contact and this mapping mission failed. But Mars was already familiar terrain, for it had been much studied as man's next stepping stone in space. This is Mars in a small telescope, the image shimmering through Earth's atmosphere. And this is Mars from the early 20th century, drawings by astronomers who believed they were observing canals. And here's Mars from Earth orbit, through the clearer, steadier eye of the Hubble Space Telescope. But no canals. Mars, bottom center, is the fourth planet from the Sun. Its solar orbit almost 2 Earth years. They've much in common, but Mars is only half the size of Earth. It's also less dense, has weaker gravity and a thinner atmosphere. But it does have polar caps, seasons and a tilted axis. Without the cloud and atmospheric problems of the Venus probes, Martian explorers have delivered pristine data. They've photographed valleys and channels, morning frost and fog, great canyons, even a landslip. Here again, closer to. The atmosphere in profile. And ice. A flyover reveals a thick polar cap. From Earth, the northern cap can be seen by telescope. In summer, the cap recedes as winter grips the southern pole. This southern cap is largely frozen carbon dioxide, the northern water ice. The caps are riven by great terraced crevasses. They've been formed, it's thought, as the climate has repeatedly cooled and heated, erosion caused by melting ice. From the poles outwards, the Martian surface has been shaped by wind and weather. And by impact crater, Mars is peppered with them. Volcanism has been important too. This is Olympus Mons, the biggest volcano in the solar system. An appropriate springboard from which to fly this dusty, arid world. Hoving into view, the 3 volcanoes of the Tharsis Ridge. To their west, Olympus Mons. Little wonder astronomers mistook the surface shadings for canals or continents, even vegetation. In fact, they're differing geological textures. Now, with data compiled from the American Viking probes of the 70s, we swoop on this desert landscape. First, a glide over Mariner Valley, the planet's most extraordinary feature. A rift that could stretch from coast to coast of North America. There's cloud below as we position for a swing over the Tharsis volcanoes. Martian cloud, like Earth's, is water vapor, but there's less of it. Overnight frost, burnt off by sunshine, forms mist in the canyons. Mars is chilly, but near the equator at midsummer the temperature could reach 25 Celsius. A low-level turn for a buzz down Mariner Valley. And there's Arcea, the southern triplet of Tharsis. Pavonis and Escreus. Three gigantic shield volcanoes like those that sprang from the Pacific to form the Hawaiian Islands. Mars has two little moons, Phobos and Deimos, probably captured asteroids. Pictured by Viking, they are lumpy rocks measuring just a few kilometers. Phobos is heavily cratered. Deimos is smoother and smaller. Both have dusty surfaces. The Soviets had an ambitious plan to explore Phobos, a craft to drop probes on the surface. Sadly, just as their work was to start, contact was lost. This was the best image received on Earth. A Martian dawn in 1976. Within weeks of each other, the Americans had soft-landed Viking 1 and Viking 2. This is what they found. A lifeless desert, rusted red by iron oxide, midday temperature -30 Celsius, atmosphere carbon dioxide, 150 times thinner than Earth's. What they didn't see were the great dust storms that blow up on Mars. So big, they can be filmed from Earth as the whole globe is enveloped. But the Martian climate hasn't always been so bleak. Witness these river-like channels. And this teardrop, moulded surely by flowing water. It's believed Mars once had an atmosphere as dense as Earth's, and water galore. So why did the rain stop? One theory is weak Martian gravity, leaking atmosphere into space. No problem while volcanic gases replaced lost air. But when eruptions ceased, Mars was in trouble. The protective blanket of water vapor and carbon dioxide, which had trapped the sun's heat, disappeared. Mars became a desert, devoid of warmth and water. Future missions may yet detect water frozen beneath the surface. And mobile robots will search for life. It's a slim chance, but some biologists believe single-cell organisms could lie dormant in the Martian soil. Samples will be collected for dispatch to Earth. But who knows when man will land? Mars, of all the planets, is the closest thing to home. There are even 24 hours in a day. Jupiter is fifth planet from the Sun and first of the outer giants. A mini solar system with 4 huge moons, all visible from Earth in a small telescope. Jupiter, a gigantic ball of gas, largest of all the planets, this view from the Hubble Space Telescope. And this from the famous Voyager explorers, time-lapse, cleaned and enhanced by computer. The portrait of a colossus, turning on its axis in less than 10 hours and big enough to consume Earth 1,300 times. It was Voyager, the most successful craft in the history of spaceflight, that unveiled the great planet. In 1977, the Americans launched 2 Voyager probes for a swing past Jupiter. 2 years later, the planet filled their sights, an awesome sphere where 1,000 electric storms flashed in the clouds below. Massive belts of weather, the like of which had never been seen. Tempests and turbulence. An immense hole in the cloud deck. And the red spot of Jupiter, first observed 300 years ago, confirmed by Voyager as a storm 3 times the size of Earth. This time-lapse is from pictures radioed to Earth as Voyager closed with the planet. 2 Jovian moons and their shadows. At its center, there may be a tiny core set in pressured ice, but for the rest, Jupiter is gas, hydrogen, methane, and ammonia. And because it's so fluid, there's no history to study, no craters, no volcanoes. Had Jupiter been 10 times the size, it would have been a star, but its nuclear furnace never got started. Even so, energy released by its slowly shrinking core means Jupiter radiates more heat than it receives. This Voyager sequence shows the weather bands, circulating at different speeds and opposite directions. The red spot is an anticyclone, a monstrous area of high pressure. But how did it form? A weather band, simulated on computer, demonstrates how several storms, chasing one another around the planet, can eventually merge into a single system, a storm the size of the red spot. On the left, Jupiter as we see it. To the right, an infrared image. It shows temperature variation. Hot gas driven up from the interior is red, colder gas going down is white and pale blue. Space Telescope photographed this intriguing feature, an aurora circling the North Pole. It matches the halo of the aurora borealis over Earth, an interaction of the solar wind with the atmosphere. The Jovian aurora was visible evidence of the planet's vast magnetosphere. It's this magnetic field which deflects the solar wind, charged particles continuously streaming from the Sun. Jupiter's magnetosphere is the biggest entity in the solar system, larger than the Sun, a fact verified by the European probe Ulysses. But for Ulysses, Jupiter was a sideshow. The craft was using the Jovian gravity as an accelerator, a slingshot to escape the orbital plane of the planets. Its mission was to take measurements over the poles of the Sun. This is how Jupiter might appear from its moon, Ganymede. The rings were detected by Voyager, fine lunar debris, like talcum powder. Jupiter has 16 known moons, the tiniest discovered by Voyager, the biggest by the astronomer Galileo in 1610. Voyager's pictures of Ganymede catalogue the biggest moon in the solar system, bigger even than Mercury or Pluto. Were Jupiter a star, this would be a planet, but rather warmer. At minus 200 Celsius, the surface is an icy crust 100 kilometers thick. Wrinkles and craters, an old and unchanged topography. Beneath the crust, a mantle of slushy water riding on a rocky core. Callisto, and the roughest surface of the Jovian moons. Impact craters everywhere. The main feature, Valhalla, a basin 2,000 kilometers across, the biggest of Callisto's craters, here in artist's impression. Otherwise, in size, composition and temperature, Callisto is Ganymede's double, a planet-sized moon. But why this dearth of geological activity? One reason may be Callisto's greater distance from the tidal effects of Jupiter. Under less gravitational stress, the frozen crust has been unchanged by cracks, folds, or volcanoes. Voyager's next encounter was quite different. The moon is Europa. The surface like finely cracked eggshell. Smooth and uncratered, the whole globe is thought to be an ocean thinly covered by ice. If there's life to be found in the solar system, it'll be in the seas of this moon. Io, innermost of the big four moons, had a surprise. Volcanic plumes first pictured by Voyager 1. There they were, plus the supporting evidence of a sulphurous landscape. In a lake of liquid sulfur, a white sulfur berg. The globe was photographed in more detail by Voyager 2. Here was the most active volcanic body in the solar system. A colourful surface pulsing in the opposing gravitational pulls of Jupiter and Europa. A crust of solid sulphur 20 kilometres deep, floating on a sulphurous sea, and myriad black volcanoes. Other than Earth, Io has the only volcanoes seen in eruption. This flying pizza will be viewed again. The American explorer Galileo passes Io in the mid-1990s. But Galileo will be fishing in deeper waters. A probe will be dropped kamikaze into the Jovian clouds, there to retrieve data before it's crushed and lost forever in the maelstrom of our greatest planet. Of all the planets, Saturn is the most beautiful. In size, second only to Jupiter, compared to Earth, a monolith. Saturn's diameter is 120,000 kilometers. But like Jupiter, Saturn is an orb of gas. Were there a container big enough, the planet would float in water. Saturn's only solid features are perhaps a tiny central core and the rings. The rings are moonlets, billions upon billions of them. Lumps of icy rock, the size of motor cars. By naked eye, Saturn is the farthest visible planet. By telescope, it has rings and moons. This picture is from a powerful telescope on Earth. And this from Space Telescope. They reveal a Saturnian storm. In time-lapse, again from Space Telescope, the storm girdles the equatorial belt. Just why is a mystery. The cause could be seasonal, for the storm blows up every 30 years, the time it takes Saturn to orbit the Sun. En route from Jupiter, most information about Saturn was gleaned by the twin Voyager probes. Their show began in the early 80s. First, the great moon Titan. The photos were a letdown. Titan was shrouded in haze, but Voyager had sniffed the familiar. With Saturn barely visible through the clouds, this picture is drawn from Voyager's data. An atmosphere rich in nitrogen, like Earth's, but denser, and drizzling ethane. Lakes, even seas, a planet-sized moon bigger than Mercury. Titan could be Earth in deep freeze. As Voyager radioed home, one thing was clear. Titan, largest of the Saturnian moons, must be revisited by radar mapper. Meanwhile, a course correction for Saturn. These are real pictures, Saturn, its rings and its moons. Saturn's composition is like Jupiter's, a tiny dense core surrounded by gas, 90% hydrogen, the rest helium. Apart from the rings, Saturn's greatest difference to Jupiter is the apparent lack of weather, obscured by smog. But change the camera filters, and there are the same frantic weather bands. Voyager's task was to scrutinize the upper atmosphere. Once identified, the craft would track a weather feature. But why, compared to Jupiter, the smooth outer haze? The answer could lie in Saturn's cooler temperatures and weaker gravity. In wide shot, the weather belts are just discernible, plus 3 of Saturn's moons. The belts are streams of cloud, mostly blowing east around the planet. Westerlies are rarer. A white spot, just apparent at the top right, is a storm the size of Europe. Through a false color filter, another storm is obvious, the dark spot below the yellow band. This Voyager close-up has the storm with a pair of smaller turbulences. And here a jet stream, similar to the gales that whip around the upper atmosphere of Earth. The difference on Saturn is that they blow at 1,500 kilometers an hour, much faster than on Jupiter. So the tranquility of Saturn's outer smog belies an atmosphere of swirling eddies and churning currents. Voyager beheld a cold soup, the cloud top temperature minus 130 Celsius. To the moon Enceladus, discovered by William Herschel in 1789, scanned by Voyager 2 in 1981, now explored by computer. Enceladus was a mere 500 kilometers in diameter, 60% ice, 40% rock. A young surface. The result, possibly, of interior water welling through fissures and freezing. Another rocky snowball, Mimas, less than 400 kilometers across, with a crater the size of Mount Everest. As this Voyager picture shows, had the missile which caused the crater been slightly bigger, Mimas would have been smashed to pieces. Unluckier impacts, it surmised, created the rings of Saturn, ancient moons pulverized in cosmic collisions. The rings, lunar debris. Using a background star as reference, Voyager was detailed to survey the rings. They stretched for 279,000 kilometers. But the rings were little more than a kilometer thick, and there were thousands of them. This time-lapse revealed dark spokes. One theory is that their dust levitated above the rings by Saturn's magnetic field. Voyager's pictures ended centuries of speculation. Galileo had spotted something in 1610, but the rings weren't identified as such until 1659 by the Dutch astronomer Huygens. Until Voyager, it was still believed there were no more than 6 or 7 rings. In fact, there are 7 main bands, each comprising hundreds of rings. Voyager not only proved the rings weren't solid, it identified their nature. They're formed from billions of particles, aggregations of silica rock, iron oxide, and ice. This edge-on sequence beautifully records the gaps between the main bands of rings. The particles in the rings range from specks of dust to rocks the size of cars. They're kept neatly in orbit by little shepherd moons. Saturn's rings remain only partly understood, as does the planet itself. The Saturnian day is 10 1/4 hours, and at 1,500 million kilometers, Saturn is the 6th planet from the Sun, now just a distant beacon. There's no shortage of moons. Iapetus, a frozen rock. Dione, amply cratered. And at least 20 more. Saturn, a celestial classic. the glacial world of Miranda. A tiny ice chip, the rough diamond of the solar system. Miranda is a moon, a jewel in the crown of Uranus. Uranus, seventh planet from the Sun, broods in the dark outer regions, its axis strangely tilted, a giant. Until 1986, virtually nothing was known of Uranus. From Earth, this is all we could see. Then outward from Saturn came Voyager 2, now so distant that bigger terrestrial antennae were needed to keep in touch. With Voyager 1 heading away from the planets, Voyager 2 was alone the 5 years to Uranus. First impressions were bland. Even filters and time-lapse failed to penetrate the fog, but Voyager did confirm a turbulent atmosphere. The probe also detected a magnetic field. Its presence enabled the rotation of Uranus to be timed, about 17 hours. The rings of Uranus could accommodate Earth. After Jupiter and Saturn, this is the third biggest planet, another gas ball of hydrogen and helium with a minute rocky core. Pre-Voyager, Uranus had 5 known moons. Post-Voyager, there were 3 times as many. This is Ariel, canyoned and frosty. Umbriel, iced in methane. Titania, with a canyon to rival Mariner Valley on Mars. Titania is the largest Uranian moon. Outermost is Oberon. But Voyager's photostar was Miranda. An ice ball less than 500 kilometers wide. A miscellany of geological form. Here, a cliff 20 kilometers high. This computer flight was constructed from Voyager's pictures. Miranda's contours are the result of intense geological activity. The cause may have been the tidal effect of Uranus's gravity. The result is a delightful jigsaw. One of Voyager's most important jobs was to study the rings. Less complex than Saturn's, Voyager counted 11. They seemed to be made of little dark ice blocks. The rings could be the dust of shattered moons or the debris of an ancient collision, for Uranus may have been tilted by the impact of a body the size of Earth. Four years later, Voyager reached Neptune. The craft had been in space 12 years. Its signals took 4 hours to reach Earth. From Earth, this had been our picture. From Voyager, these were the first fuzzy close-ups. Neptune was almost the twin of Uranus, but much easier to view, a gassy sphere with a small solid core. Like Uranus, the magnetic field was inclined, in Neptune's case, at 47 degrees to the rotational axis. The planet turned once in 16 hours. Compared to Earth, Neptune is a giant, although slightly smaller than Uranus. The white strands are cirrus, high-altitude cloud. Neptune's internal heat generates more energy than the planet absorbs. The result is dynamic weather and storms like the Wizard's Eye. And upward from the eye, the great dark spot. A tempest the size of Earth. Voyager specially time-lapsed the spot. The camera holds it centrally. In reality, the spot hurtles round the planet every 18 hours. It's borne westerly in continuous gales that blow at 2,200 kilometers an hour. Before Voyager, it was thought Neptune had only partial rings, arcs, that should be investigated. In fact, they were clumps on complete rings. Neptune had two main rings and a tenuous inner ring. Its atmosphere was hydrogen, helium, and a touch of methane. Methane absorbs red light and causes the blue complexion. A glimpse of the moon Nereid, previously known. And Proteus, discovered along with 5 others, as Voyager prepared for its last mission to Neptune's biggest moon, Triton. So great were their comparative speeds that Voyager had to fire maneuver jets to align for sharp photography. Triton was odd. It had the coldest known surface, frozen eruptions, a wispy atmosphere of nitrogen, a retrograde orbit, and oddest of all, with its trail emphasized in black, a geyser of nitrogen. Here again, in time-lapse, plumes shooting 8 kilometers high, then streaming 150 kilometers downwind. Triton probably once orbited the Sun, but passing too close to Neptune, it was captured. Out here, with the Sun 4,500 million kilometers distant, Voyager's work was done. At the edge of the planetary system is the vast orbit of Pluto. Through a telescope on Earth, Pluto is a blur. In Space Telescope, it divides in 2. For Pluto has a moon, Charon, half the size of the planet. Tiny frontier worlds that for the time being can only be guessed at. Far from the paths of the Voyager probes as they plunge into the galactic depths. There's much more to the solar system than the Sun and the 9 planets. There are comets in strange and varied orbits. Some don't make it and plunge into the Sun. Others just miss. Comets are the wild cards of the planetary pack. This is amateur video of cosmic debris falling to Earth as a fireball. It was flotsam from space that probably did for the dinosaurs. 65 million years ago, dinosaurs ruled the world. They'd survived for many millions of years. Suddenly, they disappeared. Their demise is increasingly attributed to a catastrophe, the impact of a body, possibly 8 kilometers wide, that hit the Yucatan Peninsula in what's now Mexico. The result was continuous winter, as a vast cloud of dust and water vapor enveloped the globe. Along with most other living creatures, the dinosaurs were gone. It's from the Oort cloud, a halo of debris beyond the farthest planets, that comets are drawn. They're attracted by the gravity of the Sun. A comet is a dirty snowball, a relic from the formation of the solar system. Now, as it nears the Sun, an incredible metamorphosis. It begins to effervesce. The warmth of the Sun causes vaporization. Gas and dust stream off as a tail of plasma. By now, the comet is in close solar orbit, its tail blown backwards by the solar wind. Only for a short time within the inner solar system does the comet have this classic shape. Its tail will disappear. A photograph shows its features. The nucleus is shrouded in dense cloud, the coma. There are yellow tails of dust and a straighter tail of ionized gas, fluorescing blue over millions of kilometers. The most famous comet is this one, Halley. The great ellipse which Comet Halley describes through the solar system takes 76 years. From its farthest point beyond Neptune, Halley hurtles towards the inner planets. The comet last rounded the Sun in 1986. For us, it was Halley's first space-age appearance. As the comet began its return to the outer reaches, 5 robot explorers raced to take a look. 2 Soviet, 2 Japanese, and a European probe, which would pass through Halley's coma. From well away, the Soviets measured the temperature of Halley's nucleus, a surprisingly hot 40 degrees Celsius at the surface. The Japanese detected a hydrogen envelope spread for 20 million kilometers. But the European probe, Giotto, was going for real contact, a plunge into Halley's coma. These are Giotto's pictures. At the center, the nucleus, 9 kilometers by 15. Gas is streaming from it at 20 tons a second, dust at 10. Battered by debris from the coma, Giotto flew to within 600 kilometers of the nucleus. From Earth, this was the best picture. But as Halley receded, its image faded. Then in 1990, it brightened. The comet, it's thought, had been struck by an asteroid, or there'd been some sort of explosion. At each swing past the Sun, a comet leaves a trail of debris. When Earth encounters the trail, the result is shooting stars. They are showers of cometary dust burning up in the atmosphere. They're periodic and predictable as our orbit crosses the trails of recorded comets. Earth is continually bombarded by tiny meteors. They streak in at up to 250,000 kilometers per hour to vaporize high overhead. Sometimes they're bigger, lumps of planetary debris from the size of a fist upwards that survive to the surface, meteorites descending as fireballs. An American videoing his office in 1992 caught this fireball in the sky over Pittsburgh. Part of it hit a car in New York. This is a typical stony meteorite, the dark crust caused by the friction of air melting the rock. The atmosphere also gouged these thumbprints on this iron meteorite. This one was probably blown off the moon by an ancient impact. And this may be from Mars. A meteorite hits Earth every 2 hours. Beyond Mars are the asteroids, a vast belt of material left over from the formation of the solar system, or from a collision of young planets. Heading for Jupiter, the space probe Galileo caught an asteroid in close-up. It had an odd shape, 17 kilometers long, pictured in 1991, the closest ever encounter. Its name, Gaspra. Pocked and battered, Gaspra was rich in metal, unlike the lighter Martian moons Phobos and Deimos, themselves believed to be captured asteroids. In 1992, a picture of something orbiting beyond Pluto. The 10th planet? No, an icy body, 300 kilometers wide. This is Chiron, another asteroid-like body, but displaying a coma, here in blue. Evidence perhaps that comets and asteroids have similar parentage. These are radar images of asteroid Castalia, possibly 2 bodies in close embrace. And from 1992, this is 2 Tatis, which came within 4 million kilometers of Earth. Such encounters are nothing new. At any one time, 50 tiny asteroids are buzzing the Earth and Moon. The occasional major impact is inevitable. The results can be catastrophic. Like the Manicouagan crater in Quebec, a gigantic impact from 200 million years ago. And from later in Australia, Gossa's Bluff, now well eroded. And Wolf Creek, much younger, from 60,000 years ago. This one in Arizona is relatively small, but it was punched just 25,000 years ago. And it'll happen again. And what's this at the heart of Europe? It's a brand new theory, but observe these computerized images from satellite. For all the world, we're looking at an enormous, distorted impact crater, lying between the Alps and the Baltic.
The units Inner Solar System, including the Prelude, and the Outer Solar System are both available on video, priced $10.99 each. To buy the video